In this video, we'll be looking at graphs of inverse functions. In our previous video, we showed that f of x equal 4x cubed and g of x equal the cube root of x divided by 4 are inverse functions. So now I'd like to look at those graphs since we know that they're inverse functions. Let's enter those in our y equals menu. So y equals 4x cubed and y equals the cube root of x divided by 4. Now the first one, that's our 4x cubed, and our next one is cube root of x divided by 4. I want to zoom in on these, so let's zoom in. Notice that the graph of f inverse is a reflection of the graph of f across the y equal x line, and it's actually the graph of g. Now I'd like to look at some points on each of these, so let me do a zoom decimal so we have nice points. Now the point 1, 4, if we do a trace on 4, this is y equal 4x cubed. Let's go to 1, 4. Okay, so the point 1, 4, x is 1, y is 4, is on f of x, and then if we go up to this one is g, the cube root of x divided by 4, we should be able to trace that one and find four, 1. There we go. X equal 4 and y equal 1. Alright, so why is that? Why is our graph of g a reflection of the graph of f along the y equal x line? Well, remember that the way we found the inverse was we replaced x with y. So it only makes sense that inverses are if one point contains xy, then the other one contains yx. So our theorem that goes with that is the graph of f contains the point AB if and only if the graph of f inverse contains the point BA. Another theorem, a function has an inverse if and only if it is 1 to 1. And recall that in order to check to see if a function is 1 to 1, you use the horizontal line test. So you pass a horizontal line across the graph of the function, and it can only intersect the graph in one spot for each horizontal line. Definition, this is a new word. A function is strictly monotonic if it is always increasing or always decreasing on its entire domain. And then finally we have a theorem that if a function is strictly monotonic, then it is 1 to 1 and therefore has an inverse.